of view, they prioritize speed in everything they do. And when it comes to websites, speed actually helps, and it boosts viewer retention down to many other positive factors. So down to the next slide so that we start the business of the day. Now, why do website speed matters? Why do website speed matters? So this is actually a statistics, and from the statistics we can see from the first one, which is 53%, that 53% of mobile users abandon a page that takes longer than 3 seconds to load. Longer than 3 seconds to load. Now, this is to bring to our attention that no matter how patient a user is, of course, you can't deduce or just say 100% of your users will be that patient. But the little factor that they all consider, or that is, should I say, a little bit consistent in all users, is the fact that when a website takes time to load, a website takes time to load, there are higher possibility that that very user that is experiencing that bad user experience will or might never visit that website again, so long as they are alternative. So long as they are alternative. Take for instance, a user visits an e-commerce website, and instead of it to, of course, load fast, then it takes time to load. For something like that, there are many other e-commerce websites that user will just navigate and do away with yours. So for something like that, it has been statistically proven that 53% of mobile users abandon a page that takes longer than 3 seconds to load. The second one here is 1 second's delay in a page load time is equivalent to or is equal to 7% reduction in 7% reduction in conversion. Now, what is this conversion all about? Conversion is more like the ability for a user or user retention or a user to click any link on your website. So the fact that we say there is a 7% reduction, you might, from your own point of view, you might feel like it is just something normal. But then from a business point of view, you will come to understand that that 7% reduction can cause a lot of harm at the long run. Take, for instance, a company that makes, let's say, $10 billion yearly, that's annually. A 7% reduction can result to a loss of $10 million. So you might just feel like is something, 7% is something fair, is something small. But those once you start accumulating those time frame and the rest, you come to understand that in 1 year the company is losing $10 million out of the 1 billion it's making annually. Then check it for 10 years, check it for 20 years, and you'll find out that the damage caused with time will be very, very, very high. Now, they said the third point under why speed matters, the 10 milliseconds faster loading time is equivalent to 1% more revenue for Amazon. So this was a statistic that was proving that just for a page or just for a website to load, just for a website to have a 1% load time, that's 100 milliseconds, which is equivalent to 0.1 seconds. For Amazon, it generates 1% revenue. Just like the example I gave with the 7% reduction in conversion, 1% you might feel like it is small, but then when you accumulate the results over time, then you come to understand that is generating a lot of money. And as well, if it's the reduction part of it, you come to understand that, or you come to find out that the company is losing a lot of money. Now, this brings us to an important question. What causes a slow website? What causes a slow website? The first one I have here is unoptimized image. Unoptimized image. Now, one of the factors that most developers do check when building a website, the important factors that they first of all prioritize is image optimization. Image optimization. Because once you click on a website or you visit a website, what normally does is your browser downloads the content of that website. So let's take for example now the image. Let me say a slider image that is on your website. The first image there, which is a slider image. Let's say for example, each of the images are like 5 MB. Let's say 10, no, 10 is too much. Let's say 5 or 6 slider image that they are like 5 MB per image. You come to understand that your website, first of all, needs to download that content. And with the image being that heavy, or yes, with the image being that heavy, it's cause or it adds to the slow time of the website. So unoptimized image causes a website to slow. What we have here, we said large uncompressed image are the number one culprit behind slow page loading. The second one we have here is no caching strategy. Now, what is catch? I don't know if I pronounce it. Okay, sorry, I had it. What cache does is it simply stores the content that it has downloaded on the browser. It simply stores the content that it has downloaded on the browser. Now, the important factor in this cache is the fact that after downloading the content, what it does is it saves, or should I say, it prevents the browser from downloading the content again when that same user visits that website. Now, let's take for instance a website that has a logo, a website that has a logo. Now, I visit the website. What Cache does is some content on the website, it downloads it and store it on the browser storage. So let's say 2 days time, 3 days time, I decide to visit that website again. You are no longer stressing the browser to re-download the whole content. What the browser does is it goes to its local storage and it checks, is this content there? If yes, it brings the content back instead of the browser downloading everything entirely again. When we go further, you'll get to understand that the cache can be equally stored in the sense that you can set a time frame for its validity, and once that time frame expires, the browser has to re-download those content again, but we'll get there later. The third one I have here is no code splitting. Sending the entire JavaScript bundle upfront make initial load slow. Now, the idea about no code splitting, there are some dev that once they are building, let me just say some unexperienced dev, because most experienced dev tend to split their code so that they won't have to bombard the browser with downloading the entire JavaScript content. Take for example, let's say you're working with React, you'll come to find out that if you look at the tree, if you look at the tree, you'll see there'll be the main JS, there'll be a vendor JS depending on the content of the website, and there'll be, depending on what you name it, maybe script, I say script, vendor JS, maybe cat JS, you get, depending on what you name it, main JS and the rest. Now the idea is once a user visits the website, the browser downloads the most critical JavaScript that it needs for it to function at that very moment. Now, once it downloads that critical one, the other JavaScript content will be downloaded based on demand. Based on demand. Let's say you visit an e-commerce website, and on the home page, of course, it downloads the content, but at that moment, the browser doesn't download or won't download the cart. Let's say the cart where the user gets to pay for the goods that he or she bought. It won't download because at that moment the browser doesn't need the JavaScript for that cart, so it downloads the only one it needs for that moment. Now, when the user navigates from there down to the cart, what happens? The browser downloads the JavaScript for that content. So for something like that, it prevents the user from bombarding the browser with a lot of content to download at that very moment. The next one here is our render blocking JS. Now, for some code or some JavaScript code, there are some cases where, let's say, you send a HTML request. There are some cases where, as it is downloading the HTML request, let's say on the line of the script or on the line of your text, there's a JavaScript there. So what it does is, instead of downloading the whole HTML content at that moment, it downloads, then it gets to the point where it finds that JavaScript content. What happens then? It leaves the HTML is downloaded, then it downloads the JavaScript content. After that, then it continues downloading the HTML, the other content on the website. Take for example, a website that has animation, that has to do with animation. At the first click, what happens? The user downloads of course, the HTML content on the website. Now, but it has animation and it needs to load that animation. What happens is, for some cases, you might even see a blank screen, then the animation start loading. After loading the animation finish, then it now goes further to continue downloading the other content of the website. The next one here is too many HTTP requests. Each request add latency. Too many small files hurts performance. You might think that, okay, it's just the files are not that heavy, but then once they are much, it hurts performance. No CDN slash poor hosting. When we get further, I will explain that this aspect of CDN, not to waste our time. Now the next one we have on our slide is lazy loading. Now, what is this lazy loading all about? Lazy loading is a method or an aspect where the browser, instead of downloading the entire content of the website, what it does is it downloads the only one or the content visible to the user. Downloads the content visible to the user. Take for example, you visit an e-commerce website. I love using e-commerce websites as an example because it has a lot of, should I say, a lot of stuff there that we can use to explain. Let's say a user visits an e-commerce website. What happens is, for the content visible to the user, visible on the screen for the user, it downloads those images and those contents. Now, the ones that are not visible to the user, it doesn't download it, except or until when the user scrolls to that section of the browser. That is when it downloads the content visible to the user. So what this does is, based on the topic, we're trying to reduce downtime. So what this does is it's reduce the downtime, of course. It reduces bombarding the website with a lot of content to download at a go, and it equally increase speed. It's equally increase speed in the sense that the only contents that the user needs, that is what the browser downloads at that moment. Now you can see this script beside the, okay, you can see the script here. So adding a lazy loading is as simple as ABCD. What you just have to do after your image source, the photo there, then the next thing is just add loading, then in quotes you put loading. Alternative, you can put anything there, and that is just it. When the user gets to that point of his viewpoint, the browser downloads the content there. Now let's look at what caching is all about. Initially I've already explained a little bit about this caching, so I won't really dwell much on this because that's already been explained earlier. But let's look at what browser cache is all about. From here, we said it stores assets locally at first visit, controlled via cache control header, subsequent visits, and near instance. So what this simply means is, at first visit, just like I said earlier, some contents on the website, including the images, logo, depending, it downloads those content and store them locally. So when that user visit the website, instead of re-downloading the whole content again, it just goes to its storage and check, is this content there? If yes, it returns it to the browser. If no, then it downloads it. So now what this little request we can see here, the cache control. This one, you are telling the browser that the maximum age you want it to store this content is for 31,536,000 seconds, which is, I think, is equivalent to a year. So now you are trying to tell this browser that I want you to store this content for a year. After a year, re-download the content. And after re-downloading it, based on the maximum age you set, it stores it again. Now, this immutable that you can see here is simply telling the browser that this content, there is a high possibility that this content won't change. Now, you can use this immutable for some JavaScript contents that you are predictable, or that you are predicting and you are very sure that will last for a year, or the its aim can last for a year before it is being changed. Let's say you want to update the website or upgrade something, then you are giving the browser assurance that you can store this content for a year. Then after that, re-download the content. After that, re-download the content. The next one is CDN cache, and CDN simply means content delivery network. Content replicated across global edge node reduce time to first byte by serving from the nearest location. Now, what CDN simply mean is a global network of service distributed across many locations. An example of them, we have your Cloudflare, we have your Amazon, we have I think Fastly and the rest. There are many more. There are many of them. So now what this does is, instead of your browser, okay, let me use a better example. Without CDN, a user visit a website that without CDN, what happens is the browser, if there's no CDN catch, the browser has to download some content Now, the disadvantage is, let's take for example, the CDN is located in London, the user is in Nigeria. Now, that user in Nigeria will experience, should I say, will experience lower time compared to a user that is accessing that website from London. Now, the idea is, with no CDN catch, the user from London downloads the content fast. The user from Nigeria will have to wait, or before he gets the content, it will be more slower to him. I don't know if I'm making sense or if you're understanding me, but that's simply the idea behind that. Now, how can we help to prevent this? For something like this, there are many CDN located across the globe. Now, for somebody in Nigeria, he'll access the African node. For somebody in India, that's the Asian country, will access the Asian node. For somebody in United States, to access the node for that location. Now, what this help is that instead of the user in Nigeria accessing the node from Europe, he will just have to access the one from Africa, and they still serve the same content. They still serve the same purpose. The help is just that the user from Nigeria won't have to spend a lot of time before he gets that content. The African node can help the user to receive that content as fast as possible. Now, back to that image optimization that I explained earlier. Now we can see the format size comparison. The first one, we say choose the right format, and we can get to see that PNG has, you can see the size of PNG on my screen. You can see the size of JPEG, WebP, AVI, and the rest. Now you come to understand that image doesn't necessarily, how will I put it? It's not about how beautiful your image is, but what the important factor is, how small is the image And not just it being small, does the content of the image still, is it still visible? If yes, if you can make an image smaller, that's in size, and you still don't affect the content of the image in the sense that it is still visible, the quality of the image is still there, then why not reduce the size? Why not reduce the size? Because it being a smaller size, let's say 100 kilobytes, you're helping your browser instead of it spending a lot of time downloading an image size of 5 megabytes, 6 megabytes, with an image size of just 100 kilobytes that still have the same quality and everything. Why not use it? So we can see, choose the right format. WebP is 25 to 34% smaller than JPEG. AVIF is even smaller. Then you are advised to use SVG for icons and logo. To the next slide. Now, code splitting. If you remember earlier, I spoke about the fact that once you visit a website, what happens is that the browser tries to download every content. That's if you are not the type of developer that splits your code, it downloads the code and every content on the website. Now, without code splitting, we can see for this bundle.js, for the entire app, the JavaScript used was embedded in this bundle.js. You'll come to understand that the browser downloads the entire JavaScript content. And from this example I gave you, you can see that it's just an example that the bundle.js is 2.5 megabytes. You might think it's small, but for the browser, it's actually big and heavy. But now with code splitting, what happens? You can see the way I splitted the code. There are many ways you can split your code depending on the content. For here, we have main.js, we have vendor.js. If it's an e-commerce website that has to do with carts, you can add your cart.js. There's a dashboard, there's a setting. Now, from this code splitting, we can see that the main.js is the critical JavaScript. In fact, your browser needs this main.js for it to start, should I say, functioning at the first go. So what happens is that your browser gives priority to the main.js. Then let's say the user decides to click dashboard or settings or vendor. What happens? The browser now downloads the content for that very JavaScript. Now, what happens is you help your browser to load fast. Critical code load first. The rest are loaded on demand. If the user happens not to go to those sections, they will not load. They will not even download. And it will save time, save data, and many other things. Now, the seventh slide is measuring performance. Now, for every developers, it is not just about building a website to look so beautiful, too much animation, nice, this and that. What we actually see, or what they actually look at, is performance. It's performance. And the first one I have here is the largest contentful paint, which is how fast is the main content visible. Now we can see that once the main content on your website loads in less than 2.5 seconds, it loads in 1 second, then it is a very, very, very good uh, it's a very good LCP, in the sense that it loads fast. Your user doesn't have to wait a lot of time, even though it's 3-4 seconds before the main content are visible to him. So a measuring performance that has a less than 2.5 seconds LCP is recorded as a good performance. The second one we have here is your FID/INP, and the FID simply means first input delay, and this slash, the other one simply means interaction with next paint. And the first input delay simply means if a user should click a link on your website, how long does it take the user before that link initiates, or before that link takes the user to where he needs to be. If a user click on a submit button, how long does it take before it submits? some developers might think all those things are not really needed. They are not, users doesn't check all those things till you jam a user that works on time or that works with time. Then you come to understand that every little delay every little delay can cause harm, not only to the developer but also to the business or to the consumer aspect of it. So a good FID/INP less than 200 milliseconds is recorded as a very, very good INP. And for here, we said how fast does the page response to inputs, just like I said earlier. You click on this, how long does it take before it initiates? The next one is CLS, that's cumulative layout shoot. Does the content jump around unexpectedly? Does it jump around unexpectedly? You click this, does it give you this other thing or something like that? Your user self will not even, if you stress a user, if a user visit your website and you stress him, the chances of that user not visiting that website again is like 80%, because there are a lot of competition in the market. There are a lot of competition in the market. You're not the only one that has an e-commerce website. You decide to stress me as a user. Tomorrow, I'll visit another website that is quite fast and doesn't stress the hell out of me. So how can we get this, or where can we see this measuring tool? On your browser, you can just right click on inspect, and you'll find the whole measuring tool there where you can debug or see how fast your browser loads and how good all of this is. If you come to find out that it has a very poor LCP, you can start by optimizing the images and giving priority on the JS script that will load at a go, this and that. After all that, you test again. You test again. Once you are able to achieve a less than 2.5 seconds, then it's a job well done. The next slide is the best practice checklist. I just decided to add this where we can get to see what it's all about. The loading, enable JZip and the rest. Use HTTP or HTTP/3 for multiplexing. The asset part of it, convert image to WebP, Aviv, minify CSS, JavaScript, and HTML. All of this is just the best practices for us to be able to achieve fast performance on your website. The rendering, you can see preload critical fonts and key resources, different non-critical JavaScript. Non-critical JavaScript, don't load it at a go. Wait till when it is requested for before you load it. The architect part of it, we can say implement a CDN for static website, use server-side rendering for SSG and SSG for fast TTPB. Now, these tools, what are the tools and resources for us to
Sorry, Chidiebube, like you are muted though.